This is May 2013 S2, and I'm going to solve this. The first one is not a very regular sum. That means it's not something that you see every year. So what I'm going to do, I'm going to go through this very elaborately so that it's clear. The first question: a bag contains a large number of 1 pence, 2 pence, and 5 pence. And we have the probabilities. These are the probabilities. So 50% for 1 pence, 20% for 2 pence, and 30% for 5 pence. The first question is: a random sample of 3 coins is chosen from a bag. So what we have to choose 3 coins. So what can happen over here? So the first thing that can happen is we can have everything is 5, 5, 5, 5. Now we can have there is only 1 pence and everything else is 5 pence. So we can again rearrange it. Remember, it's a sample, every possible thing that can happen. So we can have 5, 5 and 1, and we can have 5, 1, 5. Then we can have uh, 2 ones and 1 5. So 1, 1, 5. Then we can have 5, 1, 1. Then we can also have 1, 5, 1. List all the possible samples of size 3 with median 5 pence. Now notice the definition of median is the middle data. It is the middle data when the data is arranged from smallest to largest. Smallest to largest. So that's what median is. The smallest is 1, then we have 5, then we have 5. This is one of the sample, and when we have 2 ones, the smallest is 1, then the second smallest is 1, and then we have 5. We can use this one because it has 3 5s. So 5, 5, 5. When it is arranged from smallest to largest, the middle data is the median 5. Then here 1, 5, 5. When we arrange 1, 5, 5 from smallest to largest, it is the median is 5. So these three are the same. If you arranged it, it would be 1, 5, 5. So the median would be 5. Again, we have a 5 over here. When you arrange it from smallest to largest, the median would not be 5. The median would be 1. So we cannot use this one, or this one. So you got the idea now. We can do the same thing with 2. So when we have 1, 2 and 2, 5, then it will be 5, 2, 5. It will be 5, 5, 2. Then we have 2 2's. So 2, 2, 5. Then 5, 2, 2, then 2, 5, 2. So let's check one more time what we have over here. So what we have is, when we arrange it from the smallest to the largest, this would be 2, 5, 5, and the median is 5. Median is the middle data when the data is arranged from smallest to largest. So these three we can use. This is not needed, this is not needed, this is not needed. Question number B is this one. Find the probability that the median value of the sample is 5. Let's find the probability. So probability of median equal to 5 is these three: 1, 5, 5, 5, 5, 1, 5, 1, 5. When you arrange it from the smallest to largest, so they have a median of 5. So the probability of 1, we have 50%. So 0.5 multiplied by the probability of 5 is 30%, multiplied by 0.3. Again, the probability of 5 is 30%. So we have this as the first probability of the first sample, and since they're the arrangement of the other ones, each one of them would have the same probability. Remember, the median is the middle data when they're arranged from the smallest to the largest. So every one of them will have the same probability. So instead of writing this over and over again, I'm multiplying it. So the next one, or, so 2, 5, 5. So the first one probability would be 20%, 0.2 times 5 has a probability of 0.3 multiplied by 0.3. So we again have 3 samples. So remember, when we find the median, it will be the same as 255 as arranged from smallest to largest. So what we have to do here, adding the same probability over and over again, we can just multiply 3. And finally we have 555, that is basically 0.3 into 0.3 into 0.3. So let's calculate this. So this is going to be 3 into 0.5 into 0.3 into 0.3 equals to this, plus 3 into 0.2 times 0.3 times 0.3. We have this, then add 0.3 whole cubed. So this is going to be 0.216. The next question is, find the sampling distribution of the median of samples of size 3. Now, sampling distribution is basically a probability distribution where you have the random variables on one side and the probabilities of corresponding random variables on the other side. So, sampling distribution of median means that the random variable is a sample and that sample is the median of the sample. So, it would look like something like this. We would have this, the random variable x would be the median, so the median here can be 1, the median can be 2, or the median can be 5 because there are 3 different coins in the bag. Now every probability has to be put over here. It's a sampling distribution is a type of probability distribution. Probability distribution has random variables and corresponding probabilities. So we know from the previous sum the probability of 5 median is 0.216. Now what we have to do over here, we have to similarly find the probability for median 1 and the probability for median 2. So let's do this. We already know what has median 1. So for having median 1, we need the sample with 2 1s and 1 5. 1 1 1, 1 1 5, 5 1 1, different arrangement of the same thing, 1 5 1. So as you can see, when we write this from the smallest to the largest, it would be 1 1 5 and the median would be 1. Now remember, there is also 1 pence and 2 pence, so we have to make a new sample over here. So suppose we have 2 1s, 1 1 2, 2 1 1, 1 2 1. Now if you pay attention, you will notice that if we arrange this from the smallest to the largest, which is the first one, then the median is 1. If we have only 1 1 and the other 2 as 2, the median would be 2. The median would not be 1. So we cannot use the second one. So this is it. So for finding the median for 1, so we have median 1 from here, median 1 from here, and median 1 from here. Remember, all of them has to be arranged from the smallest to the largest, but we are taking the samples because the samples here, although not arranged, but when arranged, they will have the median 1. That's why we are taking all of them. So altogether, we are taking 7 samples. So probability of median equals to 1. So that would be the first one, 0.5 times 0.5 times 0.5, meaning 1 and 1 and 1. Then the second one, we have 3 order of the same thing. So probability of 1 is 0.5, then multiplied by 0.5, and the probability of 5 is 0.3. So then we have 3 orders of the same thing, 1, 1, 2. So probability of 1 is 5, probability of 1 is 0.5, and the probability of 2 is 0.2. So let me calculate this. So the first one would be 0.5 into 0.5 into 0.5, that is 0.5 whole cubed, plus then we have 3 into 0.5 into 0.5, that means 0.3, plus 3 into 0.5 multiplied by 0.5 multiplied by 0.2, and we get 0.5. So the probability of this is 0.5. The next one is median 2. So again, let's think about the samples what we have. We have, first of all, the sample 2, 2, 2. Now let's take 1, 2 and 1. For that we need 1, 2, 2. Remember, if it was 1, 1, 2, then the middle data when arranged from smallest to largest would not be 2. So the different order is 2 2 1 1 2 1 2. That's it. Then we need 2 2 5. Then the median would be 2, otherwise the median would not be 2. So this would be 5 2 2 and 2 5 2. Now remember, there is one more sample we have to think about. That is, everything is different. So if everything is different, it would be 1, 2 and 5. Think about it. If everything is different and if it is 1, 2, 5, the middle one, that means the sample arranged from smallest to largest, the middle one is the median. So when we have three different items arranged like that, we could have this. First we have 1, so it can be 2 5 or it can be 5 2. Then we can have 2, we can have 1 5 or we can have 5 1. Then we can have 5, we can have 1 2 or we can have 2 1. So altogether we have 6 samples. So when we have these 6 samples arranged from smallest to largest, let me repeat, we have to assume when they're arranged from smallest to largest, then the median would be 2. So here, so median equals to 2 is the first one. Everything is 2. 2, 2, 2. That means 0.2 times 0.2 times 0.2. Or the next one we have is this 6. So 6 into everything is different. So 1 has a probability of 0.5 times 2 has a probability of 0.2 times 5 has a probability of 0.3. Or we have these samples 3 different samples. So 3 into 1, 2 and 2. 1 has a probability of 0.5. 2 has a probability of 0.2. 2 has a probability of 0.2. Plus 3 into 2 and 2 and 5. 2 has a probability of 0.2 times 2 has a probability of 0.2 times 5 has a probability of 0.3. So let's calculate this. 0.284. Let's go back and plug it in. So when the median is 1, we get the probability of 0.5. So this would be 0.5 and we just found 0.284. This is a pretty long sum. A quick overview about making samples. Now suppose you have 3 options A, B, C and you have to make samples of size 3. How many different samples would there be? First start with same. So that means you have everything same. A, B, 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 C, C, C. Then different. So this one is a bit tricky. You have to have first A then BC, first A then CB, then again first B, then again first C. You will see that you have 6 options over here. So different, 3 items, choose 3, 6 options. Now think about the relationship between A and B. Well, there can be 1A and 2B, or there can be 2A and 1B. So this covers the relationship between A and B. Now relationship between A and C. There can be 1A and 2C, or there can be 2A and 1C, and their order. We have covered the relationship between A and B and A and C. Now the final relationship is between B and C. So 1C, 2B and their order, and 1B and 2C and their order. So that's how it works. In case of sampling distribution, remember it's a probability distribution where you have the random variable and here you will have different numbers. Now, since it's a probability distribution, it's a special type of probability distribution, it's a sampling distribution. And it can be a sampling distribution of mean. Then what you do, you make the same arrangement as before and find the mean and put it in the random variables. It can be median, the one that we just did, or it can be mode, or it can be the range where we subtract the smallest value from the largest value. So we find each of the probabilities, and that's the sampling distribution.